Okay, in this video, I'm going to be going over questions 23 and 26, which are both for passage 4 from the reading comprehension section of Prep Test 85. So I'm going to have to read through this. So as I do, I may pause and have some commentary or something, but you can follow along. Sometimes I choose to highlight, but I don't really use the highlighting that much. Mostly I just try to pause and spend a little extra time when I'm having difficulty understanding exactly what is going on. So rather than just kind of skimming over the stuff that I think maybe is a little bit more complicated, I actually try to pause and spend a bit more time there before I move on, because often when it's a bit wordy or you run on sentences where there are things that I think are more difficult to comprehend, it's possible, maybe even likely, that you're going to be asked about that. And I think in part this is because the way that the reading comprehension section comes to be is that the LSAT writers actually pull from real articles, and then they will, maybe manipulate them in certain places, so that they can ask more challenging questions, so that they can kind of obscure the meaning, potentially. So yeah, I don't believe that these ever come just directly out of real articles. They are adapted for the LSAT, and so I do think that yeah, the structure is sometimes shifted a little bit. Maybe they add some vocabulary words in there, just to make it a bit more challenging. So anyways, my theory, my kind of personal theory there is, all right, if there's something that I'm struggling, where I'm struggling to connect the dots, that might just be because they've gone ahead and made the language a little bit more challenging to decipher. And are they going to do that and then not ask me a question about it? Maybe, but I think, yeah, it's just better to have a good idea of what's going on before I move to the next sentence. All right. According to the generally accepted theory of plate tectonics, generally accepted, that would be something I would note. The Earth's crust consists of a dozen or so plates of solid rock moving across the mantle, and then they define the mantle there. So the mantle is the slightly fluid layer of rock between crust and core. So we've got the crust on top, and that moves across the mantle, and then under the mantle we have the core. Most earthquakes can then be explained as a result of the grinding of these plates against one another as they collide. All right, so this is all within that generally accepted theory, right? So one thing that's like really common in all of the LSAT, well, I suppose the reading comprehension and logical reasoning sections, is this sort of idea of like, this is what people have traditionally thought, this is what some people believe, or this is what the popular theory is, or the popular belief is, and typically that's just a lead in to the author's different opinion, right? So usually they're not going to just give you a theory and just like describe the theory without there being any kind of conflict or contrast, or yeah, I almost want to say like suspicion or criticism. Yeah, and then there would just be like no issue, and it would just be very descriptive. So typically there is almost like an argumentative sort of thing, like someone is taking a stance or a position. Now that person may not be the author. The author might just be describing an issue. They might not actually have like a dog in the fight kind of thing. But yeah, it's rare they're just going to have a passage where there's like zero conflict and everybody agrees on everything, and all the facts also agree, that kind of thing. Like usually there's some kind of issue that needs to be resolved. So even before that crops up, I'm anticipating that it's going to happen. So yes, I'm paying attention to how they're describing this theory, but I'm also waiting for like the other shoe to drop, I guess. So waiting for there to be some kind of conflict. Okay, so most earthquakes can then be explained as a result of the grinding of these plates against one another as they collide. When two plates collide, one plate is forced under the other until it eventually merges with the underlying mantle. Okay, so this is probably one where you would want to visualize it and use your imagination a little bit. According to this explanation, this process called subduction. Okay, so again, we're kind of defining something, right? So subduction is the process of the plate being forced under the other until it merges with the mantle. Subduction causes an enormous buildup of energy that is abruptly released in the form of an earthquake. Okay, so the theory is basically saying subduction causes earthquakes, right? Subduction causes energy, which is released as earthquakes. So there's this line from subduction to earthquakes. Most earthquakes take place in the Earth's seismic hot zones. Okay, so another thing that's being defined here, regions with very high levels of subduction. So all of this seems to be kind of like supporting, right? All of this is supporting the generally accepted theory of plate tectonics and the idea that when you have lots of subduction, right, these collisions, then you're going to have lots of earthquakes. But this whole time they're talking about like most earthquakes, right? So it doesn't say all earthquakes, and that would be something that we could kind of like clue into a little bit earlier as well. And then we have our contrast sort of wording here, right? So this is where things flip. Contrary to expectations, however, global seismic data indicate that there are also regions with high levels of subduction that are nonetheless nearly free of earthquakes. Okay, so from what we were learning before, it was like, oh, well, subduction causes energy buildup causes earthquakes. But what if you have what if you have no earthquakes, even though you have a lot of subduction, a lot of energy buildup? What's going on there? So that's the question, right? Thus, until recently, there remained a crucial question for which the plate tectonics theory had no answer. How can often intense subduction take place at certain locations with little or no seismic effect? So that question that's the issue, right? Trying to answer this question is what the author's really concerned with here. So that would be really important. And the way I'm going about this is actually kind of similar to the way that you might sometimes read like a legal decision where you're looking for the question that's trying to be answered. You're looking for the issue, and issue identification is actually really key on law school exams. So you're given fact scenarios, and then you have to try to figure out where the facts might come into contact with the law, and where there might be actually room to have a a legal argument about what does the law actually have to say about these facts, and maybe the law is unsettled in that area. So the answer to the question, what does the law have to say about this, is still debatable, right? That's still something that you could actually have an argument about, right? So yeah, that kind of gives lawyers a reason to exist so that they can continue to argue about these things, the finer points of law. Okay, so anyways, that was a little deviation from the exercise at hand, but moving on. Paragraph 2, one group of scientists now proposes that the relative quiet of these zones is tied to the nature of the collision between the plates. So yes, the plates are colliding, but how are they colliding? In many seismic hot zones, the plates exhibit motion in opposite directions. That is, they collide because they are moving toward each other. And because the two plates are moving in opposite directions, the subduction zone is relatively motionless relative to the underlying mantle. Okay. So subduction zone is, still compared to the mantle below, which is moving, right? The mantle is slightly fluid. Okay. In contrast, right? So here we have the other type. So they talk about what happens in some seismic hot zones, right? That they are in opposite directions. But here they're moving in the same general direction. One of them is just faster than the other one. And so its leading edge becomes, the second plate is simply faster than that of the first. And its leading edge therefore becomes subducted. Okay, so the first one's not moving fast enough. So the second plate that is coming up after it actually has to go, like its edge has to go below the slow moving plate, but they are still moving in the same direction. And then we have in this type of subduction, the collision zone moves with a comparatively high velocity relative to the mantle below. So that's different, right? So we have high velocity relative to mantle, comparatively high relative. So comparatively, so it's higher velocity than, of course, the other type, right? So what I would start doing is I would start having almost like groups of words. So some that are associated with the ones where the plates are in opposite directions. And what does that mean? Okay, well, that means that the subduction zone is relatively motionless mantle, and then we have in the same general direction. Okay, so then comparatively high velocity, that kind of thing, right? And so we're sort of recognizing that the plate tectonic theory didn't explain this because it was just looking at all subduction zones the same way. But now, to explain why in some subduction zones you actually don't get earthquakes, we're actually categorizing subduction zones. And so we have some where we have the opposite direction and some where we have the same direction. And so the difference between those two could explain the different results that we get in terms of, like, do we have a lot of earthquakes or not? But really, the takeaway, I think, from this for other passages would be when you do start getting into these like complex comparisons and you have two different groups, and in this case, they're being contrasted to one another, right? In contrast, here is an important little phrase, right? So that that would be important, and noting that these are the quiet ones, right? So the quiet ones are the ones where we don't see a lot of earthquakes, right? We don't see a lot of activity, so it's quiet. And then they give a little analogy here for how the subduction occurs in the quiet zones. So rather like an oar dipped into the water from a moving boat, the overtaking plate encounters great resistance from the mantle and is forced to descend steeply. Okay, so that would be something else, right? This steep thing happens in the quiet one. descends steeply as it is absorbed into the mantle. The steep descent of the overtaking plate in this type of collision reduces the amount of contact. Okay, so we have less contact between the two plates and less friction. And the friction is what they're saying is the earthquake producing part. And then on the other hand, so now we're going back to the first type. This is where I do think the different highlighter colors actually come in handy. You can just use them to say, oh, well, we're moving from talking about type A to type B, and think about them in general terms like that. So you could look at them and, okay, well, these are the quiet zones versus the loud zones, and the quiet zones are ones where you don't have earthquakes, and the loud zones you do have earthquakes. So on the other hand, is we're actually going back, right? So we started with A, then we said in contrast to A, and then talked about B, and now we're saying on the other hand, so no longer talking about B, we're back to talking about A. On the other hand, in collisions in which the plates move toward each other, the subducted plate receives relatively little resistance. Okay, so we have low resistance from the mantle, and so its angle of descent is shallow, right? So all of these things, we have this like comparison of, but we're like on opposite ends of the spectrum, right? So up there we had great resistance, and here we have little resistance. Up there we had steep, here we have shallow. So lots of comparison, allowing for a much larger plane of contact. So larger plane of contact versus reduced amount of contact, like two sheets of sandpaper pressed together, right? So they're using another analogy here, right? So the analogy up there was the ore dipped into the water from a moving boat. And here it's sheets of sandpaper pressed together. These plates offer a great deal of resistance. And yeah, so we've got reducing contact and reducing friction. Here we have more contact, so we have more friction. And you think about this sheets of sandpaper, tons of friction. And if friction produces earthquakes, then yeah, that would explain why you get lots of earthquakes there. And it also explains why you don't get a lot of earthquakes in the other type of subduction zone. All right, then our final paragraph. This proposal, and the proposal is what the scientists have proposed, right? So they're not proposing that anything be done, they're proposing an explanation. This proposal, this explanation also provides a warning. It suggests that regions that were previously thought to be seismically innocuous, regions with low levels of subduction, may in fact be at significant risk of earthquakes depending on the nature of the subduction taking place. So it's not subduction alone that is the risk factor, it's actually the type of subduction. So even if you have a little bit of subduction, there might be significant risk if that type of subduction is that you have the two plates moving toward one another rather than both of them moving in the same direction. Okay, so according to the passage, what results when two plates moving in the same direction collide? What do we associate that with? Well, we associate that with the quiet ones, right? So all we would have to do then is we would just have to look in this sort of like pink and orange area. Yeah, and then we would look for that, right? That information. So the second plate's motion is simply faster, and the leading edge is therefore becomes subducted. So the leading edge of the slower moving, no. So the second plate is simply faster than the first, and its leading edge. So the faster one actually becomes subducted. So that one's wrong. The trailing edge of the slower moving, no, it's not the trailing edge. It's the leading edge of the faster one. So D. So we can get that directly from this section here. So D is the correct answer. Yeah, so because it's going faster, it can't just like jump ahead. So you can almost like imagine if you're walking down the street and the person in front of you is walking slower than you are, what are you going to do? You're going to have to move in order to keep up your pace. So in this case, just because of the way the plates are, they can't, it can't like think, oh, I need to, it's not like conscious. It can't be like, oh, I'm just going to move around here. I'm going to change the direction of motion. It's like, no, I'm just going to keep going. And so, yeah, it kind of like barrels into the back of the slower moving one and is forced downward. So, yeah, but you don't necessarily need to be able to visualize it or understand it. You just have to read from here what's going on. And I think being able to identify, we're talking about, type B here when they're moving in the same direction, and then quickly go to the part of the paragraph that's actually talking about that, because it's really nested in the middle. Okay, 26. According to the information in the passage, which one of the following kinds of regions experiences the most earthquakes? Okay, so lots of earthquakes are going to be anything that matches with what we have in like the yellow in this second paragraph. So regions where there's sharp descent, descends sharply, that would match up with steeply. And that's not what we're looking for. So A is out. Regions where resistance from the mantle during subduction is greatest. So actually, great resistance from the mantle is not associated with lots of earthquakes either. Regions where subduction occurs at shallow angles. Yep, shallow right here. Regions where there is the greatest amount of subduction. So the actual amount of subduction here is not as important as the type of subduction, according to what the passage is telling us. And regions where plates are traveling in the same general direction. Nope, same general direction is the pink and orange stuff, which is in the quiet subduction zones. Quiet meaning we don't see a lot of earthquakes. So it should be shallow angles, right? So the shallow angles allow for larger plane of contact, like 2 sheets of sandpaper. Lots of resistance. Lots of resistance means lots of earthquake producing friction. So those areas should have the most earthquakes. So C. Okay. So hopefully that helps. What you can see from the analysis that I did of the passage here is that if you spend that time understanding what's going on, and like in this case, it was really mostly about trying to figure out what is going on in that second paragraph, because you have, I'm going to start with A, then switch to B, then go back to A. And so if you're just skimming through really fast, you're not necessarily going to pick up on that. Obviously, I'm going a lot slower than I would have to on the real thing, because I'm spending this time explaining and sometimes going off on tangents. But yeah, the takeaway would be trying to keep track of which type of thing am I talking about, and just sort of like associating or grouping those words together. When you see that in contrast or however, or on the other hand, then maybe at that point, that's when you're going to like switch your highlighter color, because you don't want, like, you want to disassociate those ideas or those words from the ones that came previously. So that might be helpful for you. But yeah, I would recommend definitely practicing with different methods. If you have the time to really spend on reading comprehension, practice a few different methods, try to figure out what works well for you. And I do think that with LSAT prep, you shouldn't compare your performance to anybody else's. I kind of think that that's true in almost everything in life. Really just compare how you're doing today versus yesterday, right? And try to do better tomorrow. So you're on your own path. I think some of the prep books that I've read focus a little bit too much on what top scorers do. And sometimes I think top scorers just, they started out thinking in a way that was more in line with what the LSAT tests on. And so, if you have a top scorer who doesn't make any notes, for example, or doesn't read the question stem first or these different things. Were they previously scoring poorly and then they changed to doing these things and it improved their score? Or did they just kind of always do things like that because they just didn't need to use those tips and tricks because they were scoring, in the top 5%, top 1% even, without even studying. So I'm more interested in what helps my students improve rather than what the top scorers do. And I've definitely seen students improve by trying different things, looking at the passage from different angles. And even if some new strategy seems, to be decreasing your score for a while, that's still valuable information, right? Like you can learn from that. Like, oh, okay, this isn't really working for me. And I do think that you have to give each new strategy that you try like a good chance of working for you before you abandon it. But don't feel like that time is just like completely wasted. I would say don't just rush into writing a lot of tests and doing as many new questions as you can. Review is extremely important. And even though there are a lot of tests available, you don't want to burn through them. It's better to go back over old tests with new strategies and with a deeper understanding and review them than to just burn through a bunch of new tests all at once, especially if you do end up rewriting, which is the case for a lot of people. You don't want to come into it with like, having no new tests to practice on and just only going over those old questions. You kind of need the new tests, that the ones that you haven't seen yet to judge how you're going to perform on the real thing, right? So lots of important practice and review on the same group of tests, a bunch, and getting to know those questions well. So I don't know, I would say, take 5 to 10 tests and go, okay, I'm just going to like do these ones a whole bunch of times and kind of tear them apart and look at them from a whole bunch of different angles. But at the same time, I'm going to have a plan where I, when I feel like I've made a breakthrough, I'm going to test myself. I'm going to go ahead and kind of book for myself an administered exam, take it in exam mode on the online platform, and get my score at the end, and see, okay, like have I really improved in understanding, or was I just kind of memorizing the answers to those specific questions that I was doing over and over again? Because that's not the goal, right? The goal is to understand why the correct answer is the correct answer, and how could you potentially use what you learned on this type of question or this type of passage or stimulus or game to like apply or transfer to another that's similar. Yeah. So I think that's enough of me just going on and on, but hopefully this is helpful. And yeah, happy studying, and let me know if you have any other questions. I have been kind of busy. I had some unexpected busyness come up, but hopefully I'll be able to answer more questions the rest of this week and this weekend. So yeah, and if you do at any point want to contact me about like actually having private sessions with me, my website is primaprep.com. primaprep.com. So that's primaprep.com. Yeah, so I did have somebody ask me about teaching the other day. So yeah, if you're finding me here, then that's how you can get in touch if you are really interested in that. But you're also welcome to just leave comments and ask me, and I'll try to answer your questions when I have time. Okay, have a good one.